Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the JWT attacks module titled JWT authentication bypass via unverified signature. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs. Do a search on JWT labs and select lab number 1 titled JWT authentication bypass via unverified signature. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. Due to implementation flaws, the server doesn't verify the signature of any JWTs that it receives. To solve the lab, modify your session token to gain access to the admin panel at /admin, then delete the user Carlos. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. Alright, so the target goal over here is to modify the session token to gain access to the admin panel and then delete the Carlos user. And this is an authenticated exploit, and so we do get creds in order to perform the exploit. Alright, let's access the lab. Now notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Alright, before we head into the lab, notice over here that I have the JWT editor extension. We're going to need this extension for all the labs, so I recommend that you download it. In order to do that, you click on extensions over here, go to the BAP store, and then go to the J category and click on JWT editor. From there, and I'll make this a little bit bigger. From there, you'll see an install button. Click on the install button and it should install the JWT editor extension. Now over here, I do have it already installed, and so I have a reinstall button. However, if you don't have it installed, you should see an install button. After you install it, go to the installed subtab and make sure that this box is checked so that the JWT editor extension is applied in your proxy and in your repeater and the rest of Burp. All right, let's make this a little bit smaller. Go to proxy. And the first thing that we're going to do is log in with the credentials that we were given. So the password was Peter, hit login. And notice over here, immediately this gets highlighted in green, which means that it does contain a JSON web token. And the way it identifies that is pretty much the encoding. So you could see over here, this is base64 encoding, and it indicates there's a JSON web token that is being used in the application. So I'm going to make this bigger one more time. And if we look over here, when we log in, it takes in a CSRF parameter, the username and the password. And if they're correct, it sets a cookie for the user. So the session cookie over here, and that contains the JSON web token. Now the JSON editor tab that we just installed adds the JSON web token subtab over here. And so it automatically decodes it for you. And it also allows you to modify the token. However, we're not going to do that over here. We'll do that in Repeater because it's much easier. So we're going to click on the /my_account page, right click and send to repeater. And in repeater over here, if you click send, you could see it's a 200 OK. And for the JSON web token tab, you could see over here that this is your serialized token. This is the decoded version of the token. So it has 3 components, just like we learned in the theory video. There's a header, a payload, and a signature. The header usually includes the algorithm that is used to sign the token. The payload usually includes the different authorization permissions that you have. And then the signature is just the signature of the token to ensure its integrity. So if we look at the header over here, you could see there's a KID parameter, which indicates which key needs to be used to sign the JWT. So this is used to look up the correct public key because we are using a public key algorithm over here. The payload includes an ISS parameter, which identifies the issuer of the JWT, which in this case is Portswigger. And then we've got the expiry date of the JWT. This is written in epoch time. And then we have the subject, which is the user that we're currently logged into. All right, so there's quite a few attack vectors that you can apply when you encounter a JWT token. So what we're going to do with these labs is we're going to try each attack vector. If it doesn't work, we'll move on to the next one. So the first thing that I usually do is check if the JWT signature is verified. So I've successfully exploited this in one application during my lifetime as a pen tester. And the reason this was possible is because the developers essentially confused the verify and the decode functions. And so they assume that the decode function automatically verifies the token. However, it's just decoding it, and you actually do need to verify the token. I haven't seen it in any other pen test, so I've only seen it in one pen test, and in that specific pen test, it allowed me to log in as any user, and so I was able to compromise the entire token. And that's exactly what we're going to do today. So we're going to go to raw over here. The first thing that you check for when you want to apply this attack is essentially if you click send, you get a 200 OK because you're logged in as that user. However, if you remove a portion of the signature, let's say we change that to W, hit send, we still get the 200 OK. Now, if you alter any component in the signature, the verification component in the backend should fail, and so you should get an unauthorized message. However, over here, no matter what we alter, so I've changed the last 3 characters to W, hit send, we still get a 200 OK, and we're still logged in as the regular user. And so right now, the next step is to try and identify a more privileged user so that we could compromise the application. And to do that, I'm going to see if there's an admin panel. So /admin, hit send. Okay, it looks like there is an admin interface. However, it's only available if logged in as an administrator. So let's see if we could change the subject from our regular user to the administrator user and see if our token gets accepted. Since the signature is not verified, this attack should work. So we're going to change it to administrator. Over here, it automatically performs the new encoding for you. Go back to raw, and again, it doesn't really matter what the signature is. It could be just any random set of characters that you generate. Hit send, and let's see if it works, and it does. So first of all, we get a 200 OK message, and if you render it over here, you could see the admin panel. Now, if we copy this entire token, and go to our browser, right click, inspect, and go to application, and then go to the cookies and put in our token over here in the session cookie, we should enter the administrator's account, and we do. Here we go. This is exactly what we're seeing in the proxy. So we were able to successfully exploit this vulnerability and access a privileged account. In this case, we're accessing the administrator's account. Now, to complete the goal, we do need to delete the Carlos user. We could do it from the browser, but I'm just going to do it through the proxy. So I'm going to look up Carlos and copy the path that is used to delete the user. Put it in here. Hit send. You get a 302, and then if you follow redirection and check if it deleted the user, and here we go, it says user deleted successfully, and you could see over here now you only have our regular user account and Carlos is no longer available. All right, so we successfully completed the lab by exploiting the vulnerability manually. Now let's script it in Python. If you're new to my videos and wondering why I script my exploit, it's because one, it makes you understand the lab at a much deeper level. So when you do actually have to visit all the requests and perform the entire exploit without actually using an extension like the JSON Web Token, you will need to understand the technical details behind how JSON Web Tokens are encoded and decoded. And so you'll just get a better understanding of how these technologies work. And then 2, you have a script that using just point and click allows you to perform the entire exploit by just running this script. And so it comes in handy when you're providing proof of concepts for a client. And so we're going to script the exploit for this lab and then probably the next lab. And then for the remaining labs, we won't be scripting the exploits just because we'll require other tools like Hashcat. And if you're using other tools, there's no use of scripting the exploit. All right, so the first thing we're going to do is import all of our libraries. So the request libraries, which allows you to perform HTTP requests, and then the sys library, the URL lib3 library. And then we're going to say from BS4, import beautiful soup. This will allow us to extract certain strings from the request. We're also going to import the JWT module and the base64 module. All right. And then we're going to disable insecure warnings. So URL lib3.disable warnings, URL lib3.exceptions.insecure request warning. And then we're going to set our proxy settings so that all the requests we perform in burp get sent to our proxy. And the reason we do that is so that we're able to debug our script if it doesn't work. So it's extremely hard to figure out what's going wrong with your script if you don't actually see the requests that are being performed. And so usually if we run into an error, the first thing that I do is look at the request that is being performed in the script in burp. And this way it helps me identify what I did wrong. So 127.0.0.1 and port 8080. Okay, this looks good. The next step is to call our main method. So name is equal to main. Then call the main method. And we'll define the main method over here. So we're going to say if the length of the command line arguments is not equal to 2, then I want you to print the usage instructions and the example instructions. So specifically for this script, the way we want to run this script is it just takes in the name of the script and then the URL that we want to exploit. And so there's only 2 command line arguments. If the user enters anything other than 2 command line arguments, then we're just going to print the usage instructions so that the user knows how to use the script. So it takes in the URL and the name of the script. So it says rv0. And then we'll also print an example. So again, name of the script, and let's say www.example.com. Okay, and then we'll exit the script because the user ran it incorrectly. All right, this looks good. Now let's assume the user did run it correctly. Then we're going to take in the second command line argument and we'll set it to a variable URL. And then we're going to create another variable called regular username, which is the username of our regular user. You could have taken this as a command line argument. However, that's not going to change. And so I figured I'll just hard code it in the script. And I'll do that for the password as well, which is bad secure coding practice. But it's a test script, so it's okay. And then we're going to create our session request, so .session. This will help us to maintain the session across different requests. All right, so the first thing we want to do is log in as a regular user. And we're going to do that using another function. So the function is going to be called login. It'll take in the URL, our session object, the regular username, and the regular password. Now we need to implement this function, and we'll do that right over here. But actually, before we do that, we'll say rest of code over here so that we could get back to it. So the steps over here is to first log in as the regular user, and then we need to alter the JSON web token of the regular user so that the subject over here says administrator. Once it's altered, we need to delete the Carlos user, which we saw right over here. If we go back, This is the path to delete the Carlos user. So we've got a few things that we need to perform. We'll start off with implementing the login functionality. So we'll say def login. It takes in the URL, the session object, the username, and the password. And we'll say r is equal to s.get. So we're performing a get request. And we're getting the URL that is given as a command line parameter. We'll set verified to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want our request to be sent to burp. All right, so if we go back to proxy right over here and go to the login functionality, you could see over here that the login page takes in a CSRF token, the username, and the password. Now, I know the username and I know the password, however, I do not know the CSRF token. And so we need to extract the CSRF token from the get login request. So if you look at the response of this request over here and we look up CSRF token, you could see that it's being extracted from this response right over here. And so we need to first perform the get request to the login functionality. And then from there, we need to extract the CSRF token and then log in as the regular user. So we actually need to perform a few things first. So we'll say extract the CSRF token. And to do that, we'll say login URL is equal to URL plus login. And that has to be slash. And we know that because here we go. It's to slash login. And then we're going to create a new variable that will store our CSRF token. And to get the CSRF token, we're going to create a new function called getCSRF token that takes in the session object and the login URL. All right, so we need to implement this functionality before we actually log in. So I'm going to remove this and say rest of code here and implement the CSRF functionality. So we'll say def get CSRF token. It takes in the session object and the URL. And we need to perform a get request. So s.get URL. Verify is equal to false and proxies is equal to proxies. So we know we need to perform a get request because you could see over here, this is a get request to the login URL. And then we need to extract from the response the CSRF token. So notice over here, the CSRF token is in an input element that has the name CSRF, and the CSRF token is in the value attribute. And so to extract it, we're going to use the beautiful soup library. So we'll say soup is equal to beautiful soup. We'll take in the response, so r.text, and we'll use HTML parser. And then we'll say CSRF is equal to soup.find. We're looking for an input element that has a name attribute that is equal to CSRF. And then we want the string that is in the value attribute for the input element that has name CSRF. So this should extract the CSRF token, and then we're going to return it right over here. So return CSRF. Okay, this looks good. So I'm going to run the script just to confirm that there's no errors. And I want to print the CSRF token over here to confirm that it could actually extract the CSRF token. So let's save this. Go to terminal, new terminal, and I'm not sure if this is still running. And it timed out. So let's open a new instance. And to run this, we say python 3 jot attacks lab01.py, and we give it the URL of the application. So let's copy the URL, paste it in here, remove the trailing slash, hit enter, and we do get an error. So this is why I like to run it, just so that I understand exactly if there's any errors early on instead of when I've written the entire script. So over here, you could see on line 37, I misspelled requests, so it should be request.session. And I hope I didn't misspell it anywhere else. Here we go. Okay, so it's printing the CSRF token, so everything looks good so far. Let's close this off and continue writing our code. Now that we've extracted the CSRF token, the next step is to log in as the regular user. So to do that, we need to take in login parameters. And to understand exactly what the login parameters over here, we need to go to proxy and look at the login request. So first of all, you could see this is a post request to the /login endpoint, and it takes in 3 parameters: to CSRF, username, and password. So we need to take in the CSRF parameter, which is just the value in CSRF token, and then the username parameter, which is just the value in the username parameter that we took in the function, and also the password, which we also took in as a parameter in the function. All right, and we don't need to print the CSRF token anymore. And then we need to perform a post request. So s.post takes in the login URL and the parameters to the login request. So login params, which we just defined, set verified to be equal to false because we don't want to verify TLS certificates. Set proxies to be equal to proxies so that our request gets sent to burp. And in this case over here, what I'm going to do is I'm going to set allow redirects to false because I want to extract the JSON web token. And if you look over here and look at the raw response, it's a 302 redirect, and it sets the cookie in the 302 response. And so if we were not to include this right over here, what it's going to do is it's going to follow the redirect to this location over here, and so we won't be able to extract the cookie. And so instead, we're going to disable redirects and check if the status code is equal to 302. If it is, then the login was successful. And we're going to extract the JSON web token from cookies. So r.cookies, and we're looking for the session cookie because the JSON web token gets saved in a session cookie. All right, this looks good. Next step is to just return the JSON web token and then say if you don't get a redirect, we're going to print login not successful. And we'll just exit the program because if you can't log in, you can't perform this attack since it is an authenticated attack. All right, this looks good. So far, we've just logged in as the regular user. Now we need to change the JSON web token of the regular user to that of the administrator. So we're going to go back over here. The login function does return a JSON web token. And so I'm going to say regular user jot is equal to the value that is returned in the login function. And then I'll say if regular user jot is not empty, that means the attack was successful. So we'll say if login is successful, then we're going to perform our attack. There's no use of performing the attack if the login is not successful. So to perform the attack, we'll create a new function called jot signature verification attack. And that takes in the URL and the regular user JWT that we just extracted. All right, let's implement this function. So we'll do that right over here. Once we implement this function, that should complete our exploit. So let's say JWT signature verification attack. It takes in the URL and the token. So the JSON web token. The first thing that we need to do is extract the content of the JWT. So if we go back to repeater over here and we look at JSON web token, you could see that the JSON web token is divided into three components: the header, the payload, and the signature. So if we go back over here, we need to extract the header, the payload, and the signature. And the way we're going to do that is we're going to split them on the dot character or the full stop character. And the reason we do that is because they're separated by the dot character. So if we look over here, that's the header. And then over here, this is the payload. And then you get a dot. And then over here, this is the signature. And so we're splitting it based on the dot. From there, we need to decode it because it is base 64 decoded. So we'll say payload is equal to base 64 dot URL save b64 decode, and we take in the payload. Now we don't need to decode the entire JSON web token. We just want to decode the payload because that's the component of the JSON web token that we're going to be changing. So we'll say payload plus equal sign, and I'll explain this in a second. Okay, so if you don't include this component over here, you'll get an incorrect padding error. So what we're doing over here is that we're essentially padding it with a number of characters, and the base64 decode function by default, if there's any extra padding, it will remove any unnecessary padding. And so it's always good to include this portion over here so that you ensure that you have the correct padding. Even if you include extra padding, the function itself will remove it and the script will work just fine. All right, now that we've decoded it, we need to modify the token. So we'll say modified payload is equal to decoded payload dot replace. And we're going to replace the regular user account with the administrator user account. And we are dealing with bytes over here, so we do need to include B. All right, this looks good. We've successfully modified the JSON web token. However, we need it in encoded format for it to work. And so the JSON editor extension does all of that for us. However, the script doesn't. And so we need to re-encode our modified payload. And that's why I think it's a really good idea to script your exploits so that you properly understand how these tools work. So we're going to say create new administrator token. We're going to create a variable called modified payload encoded, which is just the modified payload but encoded. So base64 dot URL save b64 encode modified payload UTF-8, and now that we have a modified payload, we need to create our modified token. So we'll say modified token is equal to, and we'll use f strings over here to create our modified token. So we'll say header. The header over here didn't change because we didn't decode it and re-encode it. The payload did change, so we need to include our modified payload encoded, and then add a dot and include our signature, which did not change. So we just say signature. This looks good. Now we're going to print generated the administrator token. And I'm going to print the token itself. So let's say modified token. Okay, so I need to verify that I didn't introduce any new errors with the code. So we're going to say new terminal and run this attack again. So lab01.py, and this probably timed out. Oh, it did not. Perfect. So let's copy, paste it in here, remove the trailing slash, hit enter, and here we go. This is perfect. Let's close. Oh, it closed off my entire terminal. New terminal. And let's go over here. Perfect. It actually saved it for me. What I was trying to close off is this. Here we go. So you could see over here, it successfully logged in as a regular user, and then it modified the token to an administrator token. And this is the token over here. Now we're going to use that token in order to delete the Carlos user, which is the last step of this exploit. So use new token to delete user. So we're going to print attempting to delete the user Carlos. And to do that, if we look over here, go to repeater and go to raw, this was the request that was performed. So it's a GET request to the /admin/delete username Carlos, and it takes in as a cookie the modified token in the session cookie. So the first thing we're going to need to do is set our cookies. So cookies is equal to session, and we'll take in our modified token, which we just printed, and then we'll say delete Carlos URL is equal to the URL plus the path to delete the Carlos user, which is this one right over here. Let's copy that, paste it in here, and then we perform a GET request. So R is equal to requests.get, takes in the delete Carlos URL, set cookies to the cookie that contains our modified token, set verified to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies because we want to send the request to burp in case we need to debug our requests. And then the response of the request will save in a variable called res, and then we're going to say if user deleted successfully is in r.text, so is in the response or is in res, then print successfully deleted the Carlos user, and that needs to be in double quotes. Now, if we don't see the string in the response, that means that the attack failed, so we'll print attack was unsuccessful. All right, this looks good, and I don't think we're gonna run into any errors. So let's save it over here and perform our exploit. So new terminal, we'll say Python 3 and jot attacks lab01.py, and we need the URL. Let's see if it timed out. It did not. Let's copy it, put it in here, remove the trailing slash, and if we go to burp right over here and go to proxy before we run it, we should see the requests that the script is making. So if we look over here, run the script, and we do get an error. So if we go to 53, cookies is equal to cookies, because that's the name of the variable. I just spelled it wrong. So let's save it again, and hopefully this time around we won't run into any errors. So hit enter, and you could see over here it's performing the login request, and then it changes the token, and then it deletes the user Carlos. And if we look over here, it says congratulations, you solved the lab. Now I did notice over here I never removed the print functionality, so I'll remove it just so that it looks better when it's printing. We don't actually need to see the modified token. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. I'll include the link to the script in the description of the video. In the next lab, we'll look at another case of a JWT attack.